If a logarithm doesn't have a base number and it says log, it's an understood base 10. And on scientific calculators, there's an log key that base 10 is programmed into it. Remember that logarithms are changed to exponents by starting with your base, raising it to your exponent, and it equals the other number. We call this the argument number, so 10 to the second equals 100. Now, if you had a problem you were trying to solve, where you were trying to figure out what the log of 57 is, since there's no number here, it's an understood base 10, you can use your calculator to find that. And if you type in log of 57 on your calculator, you get 1.75587. Depending on how you're asked around it, if you're asked around to the thousandths place, the third decimal place, that would round to 1.756. So if you have an log, keep in mind that's an understood base 10. And this is, by the way, is called a common logarithm because 10 is common to our base, our number system. It's the base for our number system. Another type of logarithm is called a natural logarithm. And a natural logarithm has a base number of e. E is called a natural number. E is approximately 2.718. It's a number like pi, that it's a continuing decimal. But you have an ln key on your scientific calculators also. And that ln key is a logarithm. It's just a shorthand way of writing logarithm with a base of e. So ln. Now in some textbooks, sometimes they use a lowercase l here, so it looks like 1n. If it's in the logarithm chapter of your book, keep in mind this always represents natural logarithm. So if you have something like natural log of 5 equals 1.609, remember that if you see ln, it has an understood base of e. The log had an understood base 10. ln has an understood base e. So what this means, this is rounded off. I typed in my calculator natural log of 5 and I got 1.609437 and so on. I rounded it off to 3 decimal places. What that means is if I raise e to the 1.609 power, now this is rounded off so it won't be exact, e to this power should give me approximately 5. So that's how you work with natural logarithms. And just like the other logarithms that you've seen before, when you change these to from one form to the other, you start with your base number e. 1.609 would be your approximate value, equals 5. If you have an exponential equation and you're trying to change it to a logarithm, let's say that you have e to the second power equals 7.389, and again this is an approximation, 7.389. If I want to change that to a logarithm, to a logarithmic form, because I have an e in it, I want to remember that that is going to be a natural logarithm. So I don't want to write log base e. I want to write ln, which has an understood base e right here. And remember your exponent goes on the other side, so I'm going to put my 2 over here. And my value, 7.389, remember is called the argument, goes there. So this is the exponential form of this equation. E to the second power, e with an exponent equals 7.389. As a logarithm, it's an ln, understood base e. ln of 7.389 equals 2. Logarithmic form. So those are some examples of logarithms.